Okay, so as Tim mentioned, my name is Ryan Bales. Tim's a good friend of mine. I've known him like 10 or 12 years now or so. We've worked together a couple places through his consulting work, and he's one of the folks that got me interested in coming to work at Dialogue Tech here in our Cleveland office. And he's actually one of the people that has kind of been mentoring me in my first year or two into the data science and machine learning world. So I'm a Python developer. Don't all boo at once. And you probably asked, why am I even up here at our talk talking about this stuff? And I'm actually just interested in languages in general and ways you can solve problems. I like looking at languages, contrasting them and seeing which have better parts to do this and do that, and which is more performant and which works better on larger data sets and all kinds of good stuff. So that's why I decided to do this talk, and I actually have been doing a bunch of Kaggles recently, trying to get my mind and my pipelining in place as to how you approach a problem, both from a mindset, from a code standpoint, and from an analysis standpoint. And those are kind of different things. So I did a very easy 101 level Kaggle, and I did it in both languages just to kind of see how they both felt. And I'll share with all of you. So a quick bio. Also, don't boo super hard right away, but I spent 10 years in the .NET ecosystem. Starting off in VB, C#, did some time in both web and desktop platforms. I even, coming out of college, did, what was the preview to .NET, VB? VB6 or whatever it was, like the very early, older Visual Basic, like the pre-.NET stuff. That was a blast. I last worked at TMW System. It's been about 9 years there. They're a company on the east side over in Mayfield. They work in the transportation and logistics areas. I led their web team for about 5 years or so. Came out of college, worked at a company called Fenatech. Probably don't know them. They're like 20 people. They're an offshoot of a larger consulting engineering company called Robusys, and they do a lot of process management and engineering, and we were like their software arm. Made the jump to open source 2 years ago. I have been spending a lot of time in mostly PHP and Python, working on web apps, and a lot of our team, the data analytics team, does a lot of data processing, trying to move data throughout AWS and process stuff, and run transcription engines and save to Elasticsearch and all kinds of cool things. We run our models in Python and run all of those after our phone call's complete. Current title is Senior Engineering Manager of Data Analytics. I have a bunch of guys upstairs that work with me, really smart people that help out a lot, and we do a lot of cool stuff. So our big thing is marketing automation, marketing analytics. If you ask our CEO to come here and talk about Dialogue Tech for the next half hour, he would keep talking about how we help marketers understand the customer journey, and we help bring humanity back to commerce. So the company was founded based on the CEO trying to buy a digital camera, and he could not buy it other than through a website, and it really bothered him. He couldn't get someone on the phone to talk to him, so he built the company to help take your marketing data and tie your web and phone call data together so you get that full picture. That's a lot of what our team does, is helping to gather insights through machine learning, other algorithms out of all that data here in Cleveland. Yes, Cleveland sports fan, kind of confused by the Cavs recently over the last couple of days, the win by 40, lose by 20, or drop up by 20, lose by 3, whatever it was. I'm confused, but I'm digging it. We'll see how it goes. Anyhow, and most importantly, I'm a husband and a father to these happy two down in the corner here. My wife and 4, soon to be 5-year-old son Joshua. That was taken last year actually in San Diego, up on some mountain overlooking the water. Pretty cool. So my training and background, I went to Cleveland State University. I've done everything in Cleveland. I barely leave the state other than go to San Diego and some vacations. But I went to Cleveland State, 10 years or so in the software engineering field, 5 years in a team lead manager architecture role throughout that time, and roughly 1 year or so working on data science, machine learning type style projects. I've also tried to do some, in addition to Kaggles, I've done some online learning through Coursera. Course I'm really, really fond of. If you're early in the machine learning phase, you want to get more knowledge about it, the machine learning course on Coursera by Andrew Ning from Stanford is fantastic. And one of the cool parts about that is it doesn't matter if you know R or know Python or whatever. That's all just done in like MATLAB and Octave, just very low-level mathematical code. And it really helps you understand the underlying, like, you can start working with packages and pulling Caret and pulling other libraries to solve some of these problems, but this helps you understand kind of the guts below the surface there. I'm currently doing a neural networks course with Jeffrey Hinton from University of Toronto. I'm a couple weeks into that so far. So far digging it. Really liking, Coursera is a really great resource for a lot of online learning. So as an FYI, like I said, 1 year into all of this, so I am not an expert in R programming. If you are and you see some code up here or something that I didn't do exactly right, I have not offended if you stand up or raise your hand or grab me afterwards and say, hey, you probably should do it this way. I would encourage that. I would love to learn some more. If I can learn something, you can learn something, then we all had a good night. I'm not a data scientist. I actually come from a software engineering background. And even though I've had a couple courses, I would not consider myself near an expert in machine learning. I'm more of just fluent and aware and understand kind of the gist of how it works. What I am, though, is a software engineer who's passionate about data. I came out of school and like the web and mobile was everything. And still kind of is to a degree. But I did that for a while. And after you build your 1,000th web page that takes data off a screen and puts it into a database table somewhere, you start thinking, man, what else is out there? What else can I go do? I love problem solving. And if I can find ways to take data and solve problems for myself, for others, then that's awesome. I kind of look at myself as like a data scientist or data engineer in training. With all of us, you're kind of looking like what's next for you and what's your next step in your career, like when you grow up and things like that. And I wouldn't mind spending some more time in that field and looking for opportunities there. Like I said, I'm always looking for ways to use data to improve human life. What I really am fond of, and really doing a lot of work reading about, is healthcare. Imagine a world where just through all of your data in your EHR and all the data in EHRs of 1 million other people, your age, your weight, et cetera, if you're a doctor, rather than having to use his background in education, and doctors can miss things, so can computers, I guess, too, actually. If your computer can help your doctor kind of predict what the diagnosis should be for what you're going through and possibly your outcome, there's a lot of power in that. Same thing for assistive devices. I don't know if you've seen the Parkinson's spoon. That's really cool. The spoon that actually has, I don't know all the details, but I think it has a lot of sensors in it. And if you have a shake come on or a tremor, it actually tries to stabilize what you're eating so you can finish taking that bite. And there's some new stuff coming out now with like convolutional neural nets and a lot of image processing. There's a lot of work going on in like the MRI, X-ray field, trying to assist radiologists and predict and diagnosing certain things on your scans with machine learning. And of course, what Tim just did, natural language processing, all the stuff that we've been doing at our company is a really hot thing now too. And I kind of was reading about this last night, and I have not used NLP in the healthcare kind of space, but they actually use it quite a bit for all those documents that come in, and when they scrape and OCR all that text off and put it into your records, and all the typing someone does of your diagnoses and all that stuff, they actually can use NLP to do some analysis on all that data and try to help with the prediction and the diagnoses. And of course, if we're going to make some money on the side, why not, right? I'm pretty fond of the stock market. I was down actually at Northfield over the weekend for the Preakness, and that book you can get there, that program of like a bazillion data points about every horse that's running, that's really cool data. You can get that in electronic format. There's all kinds of cool things you can build with that. Same goes for like baseball stats, basketball stats, all kinds of cool stuff. So machine learning in the wild. It's getting more and more places every day, but a couple of examples I picked out. All of your cell phones in your pocket by now have some, at least if you have a flip phone, have some style of machine learning through like an assistive, like a chatbot, like a like an assistant like Siri or some other apps. Autonomous driving, huge. And then Tim mentioned this too, Netflix, how they use machine learning and some other algorithms to kind of predict and recommend. They build recommender systems that they can recommend based on what you like and what a million other people like that match up with what you like. They can say you may like these movies too. That's kind of how they predict, and they show you at the bottom of the screen there all the movies you may like and stuff like that. This is a pretty cool quote from Andrew Ning from the course I took. Machine learning is the science of getting computers to act without being explicitly programmed. And that's cool, because essentially you're trying to help the computer to understand how you would react as a human, how your brain would interpret something. Essentially, if you look at it back in years ago, if this, do this, else this, do this, things like that, that was how you did, that's how you handle situations, how you handle processing of events. Those events have gotten so complex now, and we're trying to interpret so many different things. You can't build an if statement to predict every single combination of words that'll be in the document or in your corpus. So being able to train a system to learn from that data and predict and determine outcomes of the next set of data given to them in the wild is a lot of power. So real quick, and this is kind of like overview stuff if you know machine learning. If you don't, this is kind of like a quick taste. 3 different like main subsets, right? Supervised learning, we have labeled examples. It's kind of task driven. You're trying to solve something. You're either doing a regression or a prediction or a classification. Regression, like a continuous value, you're trying to predict like home prices. So a lot of Kaggles going on around that space. We'll talk about in a second. Classification, like Tim mentioned, you're trying to classify like a text document, or you're trying to classify like in the Titanic problem that we're going to talk about. Did that person survive or not? Unsupervised, you have no labeled examples. It's more of a data-driven process. You're going to do clustering using like a k-means kind of approach. And at a very high level, k-means, the way I understand it, essentially you're telling this big set of data that you want to have 3 different or 4 different centroids, and you place them in random places. And as it goes through the steps of k-means, it moves them around to find the exact centroid locations if it was going to chop your data into 3 or 4 different splices. Also, anomaly detection is a really cool thing. I've read some stuff on that in the courses I've taken about like power plants and like nuclear power plants and like factories, machines on a shop floor. There's a lot of anomaly detection kind of going on with all that data coming off that machine. So the system can kind of tell when anomalies pop up and when different alarms trigger and what is a problem and what is kind of normal wear and tear on a machine kind of thing. And then the last part I have not actually done anything with is reinforcement learning. And essentially that's just learning your behavior based on feedback from the environment and the context it's running in. And that sounds really cool. I've been doing some reading about that, but I'm trying to, as a newbie kind of getting into this, I'm trying to focus more in the supervised, possibly a little unsupervised space and kind of work my way up, so to speak. So linear regression, like a prediction with this, you're predicting a continuous value. This is like a standard way you would approach like a home price calculation. Y equals mx plus b, you're plotting all your data essentially, you're finding that line that cuts that data exactly in the middle, and then for every value of x that comes in, you go up to your y and you can calculate what your prediction is. Logistic regression classification, you're trying, as I said in the Titanic problem, you have 2 classes, right? Survived or died, 0 or 1. So in this case, you're doing a lot of mathematics and you're running a sigmoid function, and at the end of the day, you're getting a 0 or a 1 from your prediction. And there's a lot more math behind that. I don't understand enough to explain it to you, so I'm going to just kind of breeze over that and say that's essentially how inside of a logistic regression is calculating. So what I've chosen to use in these Kaggles are XGBoost, or extreme gradient boosting. And this is actually a technique leveraging decision trees to kind of take a lot of decision trees and add them up and boost them to get a better result. And I did this Kaggle like 4 different times. I tried a standard logistic regression, I tuned it, and then I actually did the XGBoost and I got much better results, so it was doing something right. So So there's three components of a gradient boosting. Number one is a loss function. You have some kind of loss function. The two standard ones are like a root squared mean error or a logarithmic loss, something like that. Then you have weak learners, and traditionally those are your decision trees. And then you have some kind of model or algorithm where you can add all of those together to get your prediction out of your XGBoost system. XGBoost continued. As a new guy using R, I really enjoyed the fact that I could just go into the console and say install.packages and XGBoost, and it just popped in and it was good to go. That was super helpful. I have to go find it. I did Google how to install it, and it came up with this, so that was pretty cool. One thing that Tim showed me that as a newbie, I really like RStudio. I'll talk about it while we get into the code in a minute here, but I did not know all of the docs were actually in RStudio about a lot of these packages. So I was going out to Google and looking for all these things. So for anyone that downloads this deck, I'll post this stuff online afterwards on the forums. This is kind of the standard doc of XGBoost that I used for doing some of this work, and then I actually directly linked into the R version of this. I even linked a slide deck I found from the person that developed XGBoost. Kind of was cool. I didn't go through it in depth, but I thumbed through it last night. Thought it'd be a cool resource to share. And then I didn't know this, but I did a little searching for R packages, and I learned a lot actually. But there is a alternative package up on CRAN called GBM, Generalized Boosting Regression Models. That actually was orphaned as a 321 of this year for some errors that were not being fixed in it and things like that. So I actually linked to it in here if you want to go look at it. That was actually built on like a precursor to XGBoost called AdaBoost, or adaptive boosting. And I didn't really get into the fine details of what that part entails, but that sounded like a precursor to what XGBoost has become, and there was a package in CRAN based on that. So what is Kaggle? And by the way, I pronounce it Kaggle or Kaggle. It's just, either one works for me. Who has actually in the room done a Kaggle and submitted it, gotten a result? Sweet. Who's actually won one or come in like top 10, top 100? Anybody? I haven't either, so all good. So there's a website, kaggle.com. We're going to bounce out there in a second off of the slide deck and get into some real stuff. But it's basically a data science competitions website. They have all kinds of cool competitions. They have them from, they're hosted by random companies. For example, one dropped today that I thought was really sweet by Zillow. They want you to come in and actually try to build a better prediction model than what they currently use today. And that one looks pretty cool. But they have them on all shapes and sizes, right? They have beginner level, they have advanced levels, and anything in between. So I chose to do like they call it entry level or beginner level, like a 101 Titanic Kaggle. They have, like Tim did the quarter one. I haven't had a chance to do it yet. They have a lot of them around like image classification and all kinds of cool stuff. And they range from like entry level to advanced. The entry level ones are more for fun and for practice to get kind of cut your teeth on some of this stuff. As you go up and get further into the advanced ones, they have a lot of awards. For example, that one they dropped today, the Zillow one, I was doing some reading before I came down here. The total purse on that is $1.2 million. So could be worth playing around with a little bit. The winner, it's like a two-stage process. They do like an initial general release, and then it goes private for like the top 100, so you can get better and improve. And if you win the final selection, you get like $1 million. So, and you got to sign your model, your algorithm over to them, of course, which is fine by me. Sometimes they award in jobs. I've seen a couple of insurance companies, I think like Allstate or State Farm, that like put a problem set out there and said, the top 5 to solve this will make you a job offer. Pretty cool. Another thing that is a little less mentioned on the Kaggle site is if you've done all the Kaggles and you're good, you've solved all that, they have lots of data sets. Some submitted by Kaggle themselves, some have been pulled in from other sources, some, any of us can go up there and submit a data set if you have a clean set. And there's some cool data there you can play around with. There's a good search engine. You can look for any kind of baseball stats or whatever you want to play around with. It's also a job search. If you're a data scientist or a statistician, you're looking for work, they have like a job board on there too. I actually look at it kind of as like the GitHub for the data science community, where GitHub is for more like the developer community, It's a GitHub for the data science community. It's a very social, when I finish a problem set, I usually post my, my code on the site under my profile. You can upvote that, you can put comments on that, you can add some, some feedback to people. And it's kind of social, everyone's trying to help each other out kind of thing. Okay, the problem. So like I said, I chose the Titanic survivor prediction problem. Very straightforward, entry-level data science problem. So here is my general Kaggle process. And this is what Ryan does. This does not mean it's the absolute right way to do it. This is just the approach that I've done on a half dozen or so Kaggles now that has worked pretty well for me. Your mileage may vary and your approach may vary. Totally makes sense for that to happen. So first thing I do is I go on the site and read and understand the problem. First couple Kaggles I did, I was like, man, I want the data. I'm gonna get in, download data, and just start writing some code around it. Bad approach. There are some intricate details in the write-ups that are there. Sometimes they explain the columns in detail and what they mean. So you're not guessing at what ID_6 means or whatever it might be. There is some really good stuff in there. And once I learned to kind of pump the brakes and go through the details, my scores got better, go figure. And my time to completion got better too. And then what I do next, after I read the problem and understood it, is I actually download the data files locally, open them up in Excel or some other tool, and I just look at the data. I just look at the first couple of rows and just walk through the columns, kind of get a feel for how much data is filled in, how much data is nulled out, how many NAs are available, what features are numeric, which are categorical, what means what, where the IDs are. Just kind of get a feel for what this data looks like. What's the breakdown, how much there is test and train, how much is labeled, how much is not. Then I just simply load the data set up. I don't do a lot of this. One thing I want to get better at, but at this stage in the game, after you've loaded your data in, an EDA or exploratory data analysis process probably makes some sense, trying to look for features that you like and that make sense and that look like they will have some good prediction power onto the result. Then I clean the data set. I'll walk through all that code in a second. Train the training set, predict in the test set, and submit the results. I follow these steps every time, and so far I've gotten decent scores. Okay, code time. So like I said, first things first, go to the Kaggle website, kaggle.com. All kinds of cool stuff up here. Under competitions, at the top, like I said, there's the Zillow Zestimate $1.2 million one here. I find it really interesting. It dropped like middle of the afternoon and already 20 teams have submitted. that's pretty quick. You were ready for it. You're ready to go. Way down at the bottom, you kind of see with the bar on the side, right? Like the red or harder, and it gets down like an orange, and like a blue, green, and it gets down to the easier ones. So I did Titanic. And once you get on the website here, on the actual Kaggle itself, lots of good read material on the front page. I don't think we all need like a video of a Titanic sinking. We all know what happened. And then on the data column, they give you all your data sets. Traditionally, I've seen things in CSV. Sometimes they zip it up for size. You can download that, extract it. But they normally give you a preset train and test set and an example of submission. So you know how to format your results before you submit back to Kaggle. When they build these data sets, they actually hold out like a super secret private server-only data set. And that's what they use to review your submissions on the test set. Some of the systems, some of these Kaggles that actually do a lot of prizes and money and things like that, they have a couple of different private sets on the server that they use to validate your results and predict your scores. But then going further here, there's you can look at some of the kernels that have been submitted, there's a discussion board, and then the fun leaderboard. And I think I'm somewhere around like there's 7,000 teams. I think I'm around 3,200 right now, so I'm in the 50 percentile kind of space. All right. So we'll do Python first, mostly because I do Python every day. So my normal programming stack on my Mac here is Python-wise, I use all the JetBrains stuff, PyCharm, really cool tool. I like it a lot. I use it every day at work. But for exploration and things like that, and even for work sometimes, I really love Jupyter notebooks. Do a lot of cool things with them. They're portable. They're easy. I can send one to you right now, and you could probably load the HTML up and look at it locally. When I commit to GitHub, if I wanted to send you a link to it, GitHub actually has the ability to render that out as HTML on the fly with no additional work. So you can just simply go look at the code, and you can see all the charts and all the plots are baked in line. It's really cool. So in this case, I actually did 2 different notebooks. Actually, I lied. I did 4. 2 we're not going to go through because they're basically the same code. I just changed the different model I was using. But I decided to try my hat at data exploration and see what I could do. So, and by the way, if you have questions while we're going through this, feel free to stop me. Better to ask them while you have them fresh in your head than wait till the end if you've forgotten about them. So I use a library called Pandas. It seems very comparable to a data frame inside of R. NumPy for some additional calculation, and I'm not sure what about random and for, but this function is not used in this notebook, so we'll skip it. So the first thing I do is load the data set, the training set, just from the CSV. One thing I learned kind of early on was set your index column. Telling when you're reading in what column to make your index makes your life a lot easier trying to merge and join sets down the road and everything else. Otherwise, you can get into a little bit of a sticky mess there. And then I just do a head just to make sure I got everything loaded in cleanly and see how it came in as. And then what I wanted to do here was just play around with some plotting stuff. And in the Python world, the majority of plots are, at least what I've seen, are matplotlib. That's like your standard plotting library. There's some other ones out there too. One's called like Boka, B-O-K-E-A-H. There's some other ones out there that are a little more advanced. But for a beginner like me, I just wanted to get in and learn what I felt was the standard matplotlib. So inside of this notebook, I made a figure, and then I put out a couple different plots. So I did a couple different plots here around the distributions of survival in class, and then I looked at age and survival by age. And if we scroll down past some of this stuff, and I'm kind of skipping over some of this code because I actually went on Kaggle's forums and looked at a couple different data exploration notebooks and kind of pulled some code together to play with it. Matplotlib, that's one thing I kind of like a little bit more about, at least standard plotting in R than Matplotlib, was that it was a little bit straightforward, easier to work with. Then once I do this more, I'm sure I'll get a better grasp on this, but at least the first cut was a little bit of hunt and pecking and Googling, trying to figure out where to go from here. So anyhow, threw a couple charts together here around distribution, survival distribution. On the left here, more 0 meaning died, 1 meaning survived, or died than survived, unfortunately. Class distribution, more males died than females. I think we all knew that. Down below, kind of on the left-hand side, 0 and 1, 0 meaning didn't make it, 1 meaning survived, and then by age. And you can see that as kind of in that middle range. Obviously, most of the people on the boat on the Titanic were in there probably, if I had to guess, somewhere in their 20s, 30s, 40s, something like that, maybe a little older, skewing towards the 50s. So you see a lot of darker blue there towards the top of those plots. And then on the far right there, age distribution with classes, you see the males being the yellow or orange line and the females being the blue one. 0 didn't make it, white made it, or 1.1 made it. The male line jumps up around the 0 didn't make it, and the falls down around the did make it, and then it's basically the exact inverse for the female. Down low for the didn't make it, and jumps up for the did make it. And something I played with too, I mean, something I was trying to figure out here was, what some of this data means. There was a field in the data set about classes, first class, second class, third class. I think it was tied to your ticket or something along those lines. And I think, the kind of like an airplane, right? First class ticket costs a little more, a little higher, a little more forward in the airplane. Same thing on the boat, you were a little higher up, and the more of the premier seats, not down in coach down below. And what was interesting here was when you look at it from an age standpoint, a lot of the upper first class paying patrons on the boat were in their 30s and 40s, and some of the second and third kind of skewed back towards their 20s. Like I said, I'm trying to learn what this stuff kind of means, so if anyone knows a better way to infer this data and help me understand it a little more, grab me afterwards, or we can talk about it now, or sometimes at the end of the talk. My main goal here was just to get to a place where I could take some relevant factors and try to get them on a screen on a plot, so I could start looking at them and playing with them. So that's the first notebook, just doing some plotting and some looking. I've gone through notebooks from people that are 4 times as long. They just keep playing with different ways of cleaning the data up, ways of slicing and dicing it, and ways of plotting it on the screen. So code-wise, this is actually the notebook I use to submit in Python. Up at the top, we brought pandas in again. This is all relatively similar. Where it got a little different was test data. Something I choose to do when I'm bringing in data is I load the train data set into a data frame and then the test data set to a data frame, and then I merge them together. Pandas is a really nice concatenation function. It just stacks them on top. First one, then the second one. Just loads them up. I do that for data cleaning. What I feel is a benefit. I could be wrong. My mind tells me it's a benefit, but I could be wrong with that. Because when you're doing like a label encoding on some of these features, and I do a couple down below here, I'll show you. If you label encode on each set separately, you may have some examples in your test set that are not in your train set. So you build your label encoder on the set separately, and it can't figure out which is in either set. So I like to merge together. That way when I encode the columns, I have a label encoded column that takes the entire set of that feature and generates my label encoding and then applies it to the column. That to me just seemed logical from a standpoint. Might not be if you look at it more closely, but it made sense at least when I first started doing it. And I've kind of stayed with that approach so far. So first thing I did is I selected out the numerical features. Age, fair, P-class, siblings is the SIB SP, siblings and spouse. So it's actually for that passenger, how many are you traveling with? All those ones are traveling with either a child or their spouse or whatever the case may be. Then I go and take all the categorical features out, all of essentially the non-numeric features. At least the goal I've been shooting for when I start doing this is I'm trying to get all of my features into a numerical representation that I can pass through the machine learning algorithm and get a prediction back. Something I did with the numerical features is I actually did some feature engineering. It's kind of the first time I tried this. I've not dipped my toe into trying to take features and make other features. Although, from what I've been reading, that's one of the ways you win Kaggle competitions is who can make the best features out of the data they have. So one thing I did here was simply make a family size column, adding in the siblings and the patriarch. That's what the column is. And then I did a fair per person. So I actually did the family size, and I divided fair. The fair on that row, and they kind of tell you this a little bit, the fair on that row is what they paid for the entire family. So if you divided that out by everyone that's traveling with you, that gives you the actual amount you paid per person. So I built 2 additional features there. Did a little bit of category feature engineering. I actually found this on one of the Kaggle forums I was looking at. All those different decks they had on the boat, right? A deck, B deck, C deck, etc. That's actually in your ticket or in your cabin field. So I just tried to take the cabin field and convert it out and generate a deck by taking cabins and converting it to a deck. So I had like a single letter of what deck that person was staying on. And theoretically speaking, kind of trying to get some insight off of that is, the higher the deck, A, B, C, at least one guesstimate could be that you have a higher probability of surviving if you're on the upper deck, where if you were lower, maybe not so much. That's one thing I try to do when I'm doing this. I try to think through the data and what it means, but I try not to overthink it. Because I don't want to, overthink it too far and not use a feature because of that. So I wrote a function so I do a thing called imputing. And imputing is a strategy where you take a feature, a numerical feature, and you want to just fill in your missing values. And there's lots of strategies you can use. I use a mean strategy where it takes that column, that feature, calculates the mean, and fills in anything marked as NA or null or what have you with the mean of that column. You can do 0, you can do 1, you can do some other preset numbers, other stats, and you could calculate, you could put in there. But essentially, I wanted to get a value in there for every column through imputing. Then once I do that, then I go through and normalize. Because these values can be very skewed, I normalize them down so they're a smaller set of values. And I try that was mostly trial and error. I give it a shot one day and it helped my score, so I've kept with that for the most part going forward. And then I just do a head on that data, and you can see that everything we have there is a numeric that we've converted into more of a decimal, a scale decimal approach. Then we have another function that takes and encodes my categorical features. I mentioned before, I use a label encoder. Essentially, it just takes, think of like a male-female column, right? The data set here actually for sex is male and female. You can't pass a machine learning algorithm, male and female strings. You have to find some way to represent that numerically. So essentially, I just say, take this column and convert it to labels, and take those labels, convert them to a numerical representation, and put it back into the field. So it takes and it says, okay, we have two values here, male and female, assigns them 0 and 1, and then it goes back through that column and takes every male or female and makes it 0 or 1 in that column. Something I did here too, I left the name column in. I should probably pull it out. I actually left it in just for discussion purposes, and I show in my R example kind of a difference on that. But that name column is definitely a unique number, pretty much down the road, 0 through 2,000 or maybe around the boat. So after I've cleaned up the categories, now you can see I have much more numbers, just kind of categorizing everything. I merge them back together into a clean data set, and then I do a head on that data set. I do a lot of heads every step just to kind of double check and make sure I didn't lose any data along the way. I'm constantly looking at these numbers down here, rows and columns, just to make sure that they're matching all along the process. I didn't mess anything up. That's my big thing. So that's like 101 data cleaning. There's lots more you can do, lots more fun things you can do, especially in the feature engineering side. But that is what I do. Essentially, at a high level, I take the data in and get it to numerical values that I can pass into the algorithm. So now it's time to actually really get serious about training and building the model. And I just take my clean data and split it. I didn't find a cool way to do this. I looked at the data set and saw there were 891 rows in the train set. So I just split it 891 this way, 1 891, 891 to the end in the test set. I split them back out. And then I concatenate back in the survived columns of the train set, because I didn't want to do any kind of processing on that. I didn't want to touch it. I didn't want to scale it. Didn't want to do anything with it. So I pulled it out, put it aside, and I merge it back into that set. So when I go to train, it's there. And then again, I just dump those sets out, take a look at them, make sure all the numbers look right, and we're all good to go. So then I come in here and just my strategy, when I go from data set to training, I deal in X and Y. So I take my data, my features, and that's my X set, and then I drop off that survived column, and then I just take the survived column off the clean training set and make that Y. That's just how I write my code and how I keep things straight when I'm getting to the point where I'm starting to train. So in in Python, I use a lot of scikit-learn for a lot of these examples. Huge library if you're doing Python Kaggles. Pull it in, play around with it. A lot of fun stuff under the hood there you can get into. But I'm using a function in model selection called test train split, and I'm passing in my X and Y set. I'm saying make my test size 20%, make my train size 80%. Random state of 42, and then I'm stratifying by Y, because I want to split based on, I want a equally representative set of survived and not survived in both of my sets. And I'm doing this on my train set because I want to do a validation. I got into the habit of, you can simply just come in and not do any of this, and you can just train your test set, predict on your, train your train set, predict on your test set, and submit. That's totally a viable path. I like to do some additional calculations to see how I'm doing with my modeling before I submit. So I just yank out a random validation set. So next I start, so actually what that gives me is it gives me this right here, X train, X validate, Y train, Y validate. And I use those for my next couple steps. Pull in XGBoost and import the XGBoost classifier. Inside that classifier, I call just the fit function to fit it to my train set. And I pass in train and X train and Y train. That takes a couple seconds to run. Comes back with this a trained classifier, and then I do predictions on my X validation set. So then I generate a couple different things. I generate a classification report and accuracy score. So one metric that we use at work for kind of trying to see how well the model is performing, this is kind of a bad example, I guess, because when you're doing a binary classification, essentially accuracy is pretty close. We do a lot of like 4, 5, 6 class classifications for customers' phone calls, and essentially being able to see per class how well your precision and recall are doing, what your F1 calculates out to, helps us kind of get a feel for what calls we're getting the right features out of and what calls we're not and things like that. But just out of habit, I generated one here and got precision recall and F1 score for both categories, and then my accuracy was at 78%, which I was pretty happy with. I think I was reading that if you simply just come in and take the age and sex columns, I think, out of the field, out of the data set, you can get like a 70 or 72 right off the bat. So something I was doing was helping improve that a little bit. So then I come out here and I predict on my X test and get my Y test back out, and then I generate a data frame and get my passenger ID off my text set as .index, and I just to-list my Y test and throw it into the data frame and the survived column. Once again, do another head call to make sure I got everything right, and then I save it out to a CSV, jump over to the Kaggle website, upload it, and see how well you did. And it's a great feeling to see your score go up, and it's a bummer when they tell you like, oh, you submitted a new file, it's a 74% where you were 75 before, good luck next time. That's kind of a bummer. But so that is the Python example. Any questions on it so far? Anything that did make sense, or the overall flow? Cool. Okay. So overall, this came out, when I submitted it, at a 77.99%, pretty dang close to 78% accuracy. My rank was 3277 out of 7,000 submissions, and I was about 1,000 above Tim's score, and that made me happy. So I'm okay with that. First thing I told Tim the next morning when I came in, look at my score. Okay, let's jump over to R. So again, like I said, first foray into R. This is literally the first. So my experience in R, I did at CodeMash last year. Actually, this year, I guess you would say. Back in January, I did like a full day R boot camp, like pre-compiler, 8 hours of straight R. That was cool. But with some of those things, you're kind of taking code from one place, pasting it to another, writing a little bit, playing with some stuff. You get some out of it, you get some you don't. I wanted to write an end-to-end. I could have taken what I did and just ported it, but I wanted to actually go through the experience of learning what packages are available, trying to search for them online, look for examples, and kind of learn how others use the language. So I didn't port. What I did is I just took those steps I mentioned on my last slide and just put a comment in the code for each one. And I put the code I needed to complete that step under it. I just kept walking through piece by piece. So first thing I noticed I really liked about R, first of all, RStudio is a really cool tool. I'm a fan. It's I think it's very comparable to PyCharm, but it has some additional things that are really cool about it. Like, for example, all the plots being baked in and how you kind of get that overall look and feel of everything in one kind of view right out of the box. But I really liked the import data set, like before I even wrote any code. Like the first thing I said, the first thing if you write any code, you pull your data and look at your data, see what your data tells you. First thing I did, import data set, pull in my CSV, and just look at it. And that gave me one of these little, a new tab with a kind of Excel view of it. I thought that was pretty sweet. I spent a lot of time, like I actually really have to have like a dual monitor set up to do a Kaggle, and that sounds kind of weird, you really need that much, but you got like an Excel file going over here with your data that you're looking at, and a Kaggle website, you got like your Jupyter notebook or something, or your tool you're coding in, you're kind of bouncing back and forth. But I really liked how like I had like a one-stop shop here where I have like my data, I have my code. Tim showed me this, I actually could do like you can pull help in right from here too. You have to go to Google for all that stuff. Really cool. And I actually used the environment variables up here to play around with stuff, and I really liked how I could just click on one of these and see kind of the breakdown of my columns here, which columns are in, which ones are string, which ones are factors, etc. And I think if I double-clicked it, it would give me a, I could look at that data right in the state of the data in that variable right here in the main window. This is awesome for me because as you saw in my Python code, I had like a head statement all over the place. That's fine, it works, but rather than doing heads all over my R code, printing everything out, I just simply would run a section, open that variable up, look through it, see how it worked, see how it didn't work, and just kind of watch and repeat. Yes?
Have you considered using Spider or Rodeo? These are kind of the same IDEs, but for Python.
I've heard. Go ahead, sorry.
They kind of have the same interface.
Oh, really?
And they have the same functionality that I think you really, really like.
Thanks for the tip. I'll have to look at that. Someone told me about Spider a while back, and I did a little searching on it, and then got pulled off another project and just forgot about it. I'm glad you brought it back up. It kind of sparked my memories of it. PyCharm is something that our data science work showed me. I started just getting into it, and there can't be any better IDE out there, right? Because why not? But yeah, I've heard good about Spider too. What's the other one you said? Rodeo?
Rodeo.
What do you?
So PyCharm also has a new update. I think it's part of their like professional package, where it has this feature as well. But then it also extends to databases, where you don't have to drop tables or drop rows through code. You can just go into some sort of interface through PyCharm.
Oh, cool.
And drop
All right.
it there, so.
And that's in the paid version, you said?
Yeah.
Okay. Yeah, I'm running on the freebie version, on the community edition.
Rodeo and Spider are free.
Okay, cool. Thanks. Awesome. So yeah, I really enjoyed the fact that I could just pull up my data set and see different states of my data. So one thing I tried to do, and I don't know what are standard packages, which ones are newer packages, so I just found a package that would work for me and figured I'd try to use it. So I pulled in dplyr, one I found called category encoders, caret, and XGBoost. And first couple lines here, I'm just loading my data set in, test and train. I follow the same approach, right? I bring it in as two different variables, and then down here I call it bind rows and merge them both together. And then I kind of made a copy of it right here, so I had a copy to spare. Then I immediately go into data cleaning. First thing I'm doing is just doing for every column that was a, this is kind of cool too. Like I can just simply, my data set, $, the field I want to work with, age in this first case, and then I can do some work on that field. Whereas before I was generating different sets and pulling other columns in and just kind of, you get like 30 data frames for a small problem, you get kind of like lost in your data frame world. This allowed me to stay in one data frame and just simply touch those features and do work on them and kind of just walk through the process. What I'm really doing here is calculating a median on that and setting it back in where it's NA on all those age, fair, parse, class. I'm doing that age twice, looks like. That's pretty cool. Nice. Double clean right there on the age column. Then I wanted to scale. And scaling was an interesting thing for me. So actually, at first what I started trying to do was I used dplyr and did a mutate on the column to convert it to a factor. And I really didn't, the factor thing was interesting to me, and I like, I'm really used to like, actually I'm wrong, that was categorical. Let's keep going. So yeah, we do our median calculations to do the imputing up top, and then we scale all of our values. This is kind of a weird thing I noticed I had to deal with. I was trying to pre-process on my all data clean data frame. I did like a comma -2 to say give me all rows, pull pull a second column out and generate my scales. That was actually, and then down below I predict my values on those columns and put them back into the clean data set. That was actually touching my passenger ID field. It was scaling the passenger ID. So I just put another line down below to pull the row name back off of the set and put it back in the passenger ID because they were the same number, which kind of a hack. If there's probably a better way to work with data than this, definitely feel free to share. This worked, so I kept going to the next problem. So then down below, this is where it kind of got interesting. Like I was saying, with the categorical features, I actually started off doing a, go ahead, sir.
I'm seeing the scaling you applied for all the numerical features, or else those features who are having the distribution, either the right or left skewed distribution. By seeing this, you applied the scaling for all the features, is it correct?
Yeah, that's actually going through working on the whole set. So that's going column by column and calculating the scale factors of each column, of each feature. And then it saves that into the pre-processed values.
But
Right.
as I know, even I am also learner,
Mm-hmm.
but as I know, which features are having the distribution, either skewed distribution, so we have to apply only for those features, isn't it?
Oh, so understanding the question. So one thing I had to look this up too, actually. I'm working on the whole data set, and there are numerical and categorical features in here. This library, I think, part of dplyr, I believe, skips over non-numeric features. So you're only working on the numerical features in this case.
Yeah, numerical. But some features is having proper distribution. It is not required to apply the scaling for those numerical features. But some of the features might be having skewed distribution. So we have to bring the data, everything like before the pre-processing, which features are having skewed distribution. We have to apply the scaling only those features. Isn't it?
Okay. That's interesting. I didn't know that. I didn't look at skew versus scale. That's a good point. I think there was an option actually. I could do a method skew in the last parameter there. I didn't play with the skewing, but
Yeah, that's what we learned.
sure. So I'd like to understand more. We can talk some other time about how you would know a feature is a skew distribution versus scale distribution. That'd be an interesting conversation.
Yeah,
But I don't personally know.
And then pre-processing of data.
Okay, cool. So yeah, like I was saying, I went through the categorical features. I first started doing them as converting them to factors, and then just as numeric on the columns to bring it back into to numbers. I found the category encoding library on Cran. I was like, I'll play this a little bit and see how it works. And it kind of felt very Pythonic, and the way I was doing it in Python, so I just kept going with it. And essentially here, for every categorical column, I'm passing in the feature and saying fit a label encoder on that feature. And then I'm saying to transform that column with the encodings and put it back into the same column. So I'm just processing each column.
I was going to mention this in your Python code.
Go ahead.
But since you're bringing up it again,
Mhm.
for categorical data, unless there's an order in the data, like you could argue, for example, in class, there's an order, right? First is better than second, is better than third. But in like name, where they're just different, right? One name or another, categorical data probably should not be encoded as numerics, right? As an individual numeric column, because that kind of implies something in the data that isn't there in order, right? So the normal way to do that in R or Python would be, or in any modeling exercise, would be to use a basis to encode those variables as many columns, right? Like a unit
Yeah.
basis. So you're going to blow up like one column with 3 categories, you probably end up in 2 or 3 columns, well, depending on whether you had an intercept or not, right? In the model, that would be the normal approach.
Yeah.
So, and I think it would improve your prediction in your
Okay.
Python example.
I'll give that a try. So I'll be honest with you. I started doing it that way. You're talking about like one hots and things like that, where you're almost doing like if you have 6 categories, you have 6 columns, and you have 0, 0, 0, 0, 1, 0, 0.
Well, that's one.
That's one way, right?
Basis, yeah.
Okay. So I tried doing things like.
Whether or not there's an intercept in the model, like how the others are going to look like.
Oh, okay. So I tried doing that, and then I found the category encoding. I was like, oh, I'll try this too. And that was less columns to work with, so I went with it. But that's a good idea. If you had an example or something of a way I could try that, I wouldn't mind trying that, see if I can get my score up a little bit. That'd be great. So yeah, I went through and did the encoding route on these. and then kind of moving back into kind of the blocking and tackling of just training a model and getting a predictive set on it. One thing I found that was interesting, just kind of caught me off guard, was you probably noticed in the Python code I did, it was comma, colon, or 891 colon, and then 891 colon 891, just split it and pulled it off. I had to give it both indices on the set I wanted, 1 to 891 and then 892 down to 1309, just the way it needed me to do it. Just one interesting thing I noticed. And maybe I was doing something wrong, but I couldn't get to work, so I tried that. So then I come down after I've split back into train and test. Once again, I do the train and validate, 80-20, I did it with sklearn in Python. I did it with caret and create data partition here in R. And then just took the index that comes back and just split it both ways into a train and validate. And all these lines down here, I'm just simply making my X train, Y train, X, Y, Y, val, X test, Y test, and getting all my data ready to go and ready to work with. Next, I took the data frames, and XGBoost requires you to convert those to a matrix. So I used data.matrix and just did the X train and Y train. I played around with a few properties here. Essentially, max depth is saying I'm okay going 3 levels deep in my trees. Forget what ETA meant. Number of threads, number of CPU threads. So I used 2. And number of rounds is just number of iterations through your data. I just picked 5. And I'm doing a binary logistic regression. And that was the method objective I passed in. Once it has a model fit, I called a predict on it with the xval and the model that was fit, and presented my values back. And then to get my yval, I actually had to do simply anything greater than 0.5. That's an interesting thing I noticed too. Tim actually helped me a little bit too. I was trying to look at the docs. I was hoping there was a way I could return back the class as predicted, where instead it returns back the probability, and you got to do just the quick math there. And there's a lot of better ways to do that probably than 0.5 or above, 0.5 and below. But I just did a pretty simple way to do it just to get some data flowing. My number one thing when I started doing these Kaggles is to get data flowing through the system as fast as possible. I won't go through all of this. I actually put a link in the code here to an R blog I found about Tim who code reviewed my stuff, didn't actually tell me about the fusion matrix stuff instead of caret. That was awesome. So I actually worked through all these different values to calculate the confusion matrix and then number of instances and classes. And then I display accuracy, F1, and the rest of the code kind of just, you saw in Python already. The one thing I really liked that I played around with in XGBoost was part of that package. I'm going to make my screen a little bigger to get this in here. This is pretty sweet. I don't know if you can see it or not. Yeah, so I did an importance matrix of my features. And this is kind of cool because I chose to leave everything in, right? I could have done a PCA and filtered out or whatever it might have been. I left every feature in, and obviously, like sex, ticket, class, things like that are way at the top. Kind of weird that name is that far up, and things like that. But this was a kind of cool way of seeing, like, obviously, like you saw from those graphs in the Python one, like male, female had a big indication of whether you survived or not. Okay. Like I was saying, I got 77.03 on the R version. And one thing I didn't do the additional feature engineering, and I wonder if I changed out those the way I'm doing categorical, if I would get that even a couple ticks higher, and that got me around 4,000 out of 7,000 submissions. So, okay, we're almost there. A couple quick tips: understand the problem and data before you started. Use the forums for help or others around you that you know. One thing I do that I like is I always work towards an MVP or baseline solution quickly. I want to get a score in and get on the board. Not so I feel good about myself, just I like to have a baseline where I can start and iterate from. I want to know that if I changed and add these features or pull that feature out, did I get worse, did I get better? Because you don't know until you get that first baseline score. And the faster I get there, the faster I can iterate and try to get better, or worse in some cases. I try not to get stuck in EDA paralysis, although I want to get better at that, kind of a double-edged sword. I want to understand more about, like most people have done, I just take all the features and just can code them and convert them and clean them up and say, go predict. If I did the actual work to do like a PCA or just do some other analysis and pull some features out, I would probably do better. And one thing I learned early on was I spent a lot of time like this. So I would quickly get my data cleaned up, get it ready to go, and there's a lot of time picking the model I wanted to play with. I want to do an XGBoost or Logistic regression or what parameters I want to pass in, things like that. That was the wrong approach. There is far more payback in your scores. Well, like Brian was saying, the better you treat your features and work with them, the better your results can become. The more features you figure out how to engineer and create, and the more you figure out how to pull out, and the more you figure out how to properly represent, the better off your scores will get. The data science part of it is a lot more important than in my opinion, than the modeling selection side of it. Pick a model you like and know how to use that every time for your first pass, play with your data more. All right, next steps. Check out Kaggle.com, create an account if you don't have one, give one a try. I recommend the housing prices prediction one. That's a really nice linear regression problem where you're predicting the continuous value of the home price. I've already done that one. I'm currently working on the Russian housing prices Kaggle, and we're over time not going to pull that up or anything, but essentially that is one that we started in the meetup that I go to with Akuya. That one I really like because it actually has different data sets to pull together, and you got to really think about how you merge data together. It has a set of all the home transactions and all the data along that, like a couple hundred features. Then it has some macroeconomic data, and it's all date time stamped. So you got to figure out the right way to pull it together, right? One quick way is you could join together the timestamps, so you have the values of the economy on the day you sold your house and train on that. That's a valid idea to try. You could think that maybe the economy 90 days out before you bought your home may have indication of what price you were comfortable paying. So you could do some kind of analysis on the 90 days before and do some medians or means depending on the feature and bring all of that in on your row. It's all kinds of cool stuff you can play around with. Like I mentioned, Zillow's dropped a really cool one today too that I might go check out tonight or tomorrow or sometime this week. Trying to get your estimates better. So Takuya's here in the back. If you're curious about doing some more meetups, he gets a group together for the Cleveland Data Science Meetup, usually one Saturday a month from like 10 to noon or so, somewhere around Cleveland, and we just pick a Kaggle and start doing it, and kind of bounce ideas around and talk through the problem and try to get to the end game. Like I said earlier, we're hiring a dialogue tech. We're hiring a software engineer here in Cleveland for my team. If you're interested, let me know, or pass along somebody who might be interested. We also started an ELP program, actually a programmer. If you know someone coming out of college or maybe went through a boot camp or something, love to talk to them about getting them into our ELP program. We just started at Dialogue Tech trying to get young graduates in, train them on our systems, and then push them out to our dev teams and other teams to help us do. I'll post these slides if you're interested. Here's my contact information, email, Twitter, things like that. I'll post all this to the meetup group, and thank you.